Thank you. Thank you. I'm gonna try and give this talk without the microphone because I just don't really like the way it sounds. Everybody okay with my volume so far? Okay. I think first thing first, I just want to say thank you, NUS Hackers, for having me back. I was invited to give a talk here back in 2022, and public speaking is not really my thing, but I kind of enjoyed the experience. And when I was invited back again, it just nice. It coincided with some interesting things I was working on, and I told Prague that like if I could pull it off, I would like to present, and here I am today. So I appreciate the opportunity to come back here. I am very nervous. I haven't done this in a while, so I apologize in advance if I get a bit stuttery or some of the concept I explain is not super clear. Please feel free to raise your hand to stop me at any point in time, and I'll be more than happy to explain to you. Okay, so today I'll be talking about man-in-the-middle magic. What I'm going to show here is how to outsmart certain SSO and 2FA defenses. It's okay if you don't understand what these terms mean at the moment. I'll slowly go through the presentation and explain to you guys. So a bit about myself. I've been in the workforce for about 5 years. I graduated in 2019 from SMU Information Systems. Thereafter, I started my first job at PwC for slightly over a year. I moved into in-house in a tech company at ExpressVPN, and I was there for 2 years. And now I'm in a local startup called Patio. It's a blockchain startup funded by Temasek and a few of the major banks. And my roles across these companies generally tend to stretch across like being a pen tester, internal red team, or a security engineer. In my free time, I enjoy sports. I love watching sports. I love partaking in sports. And recently I started skydiving a fair bit. So that's me just last week in Australia, jumping out of some place. Yeah, that's just some fun facts there. So today's talk, these are the main topics that I'll be trying to go over. The first few are going to be just context laying, just helping you guys understand the problem statement over here. It's not intended to be super technical, and I want you guys to be able to follow along the story before I get into the slightly technical parts. So we'll talk a bit about like phishing objectives, like why hackers use phishing as an attack vector. Next, we'll look a bit at some comparisons between the legacy way of phishing versus the modern way of phishing, right? I'd like to then introduce a man-in-the-middle phishing framework called Evilginx. I don't really know how to pronounce it. Some people call it Evilginx. I'll just refer to it as Evilginx for this presentation, right? This framework has been around for close to 7 years, and vendors have obviously caught wind of it, and they started to implement protections against these types of phishing attacks. We'll talk a bit about that. Then we'll move on to talking about like how to outsmart these defenses, right? I'll lastly go into where the actual problem is and why you can actually overcome some of these defenses. And we'll cover some learning lessons before we go into the Q&A. All right? So let's start. Phishing objectives. Why are hackers interested in phishing, and why is it such a potent attack vector, right? It grants you access to a host of things. One of it can be emails. Say, for example, you successfully phish an employee's email account. You tend to gain access to the organization's address list, all the email addresses. You can potentially get access to sensitive documents. Say, for example, like contracts, spreadsheets, documents, right? All part of email attachments, and you stand to gain access to it if you have access to the email. Lastly, you also can do employee impersonation. Say, for example, you hacked into a CEO's email account. You can use his email and send email to the finance department saying that, hey, I need you to tend to this invoice and secure the payment, right? And the payment can be to a bank account controlled by you as an attacker. Some of these things has actually happened in real life before. So hence, emails is actually it's like hackers consider it like a crown jewel to gain access to employees' emails. Next, how many of you have done internships? I'm not too sure about the demographic here, but like I was told that this spans across like year 1, year 2, year 3, year 4 students. Anybody done internships here before? Say, for example, at like big 4 companies like PwC. Have you heard of these companies before? Do you come across when you are onboarded into these companies, you have a host of internal applications that you have access to? And some of these applications are used to, say, for example, manage your HR details. It can be cloud-based storage applications like Google Workspace, Google Drive to store your documents, to collaborate with each other. At the same time, if you're in a tech company, you have access to internal applications such as GitHub, AWS, cloud infrastructure, cold storage places, right? All these things are super juicy when it comes to attack from an attacker standpoint, because if they have access to this, they can maybe get access to the employee PII data, salary information. They can even have the opportunity to upload malicious files for other people to download. So you can see the possibilities are pretty endless over here. Now, this segues nicely to the next point. In modern technology stacks, right? Say, for example, company X, it has 10 to 15 internal applications. Each one has their own login portal. You need to memorize how many combinations of username and password credentials, right? Step in SSO service providers. What it does is it actually allows employees to access all their internal applications through a centralized dashboard. Meaning to say, you no longer need to memorize 10 to 15 username password combinations. All you need to do is log into your SSO service provider, and then through there, on the right side here, Okta is an example of an SSO service provider. You can access all your apps here. So you don't have to log in multiple times, just log in through one spot, you have access to all. Some food for thought over here. From a user friendliness perspective, right? It actually makes things very easy for employees to access all their apps. But from an attacker's perspective, what does this mean now? Right? You have all the applications centralized under one area. It means that if you compromise the SSO account, you get easy access to everything else, right? So this is why phishing can. These are some of the crown jewels that attackers are actually interested in when it comes to using phishing, and it's a very, very potent vector in today's world. So we'll move into legacy ways of phishing compared to the modern ways of phishing. And how I like to categorize this is actually pre-MFA days and post-MFA days. MFA being multi-factor authentication. So talk about pre-MFA days, right? 10, 15 years ago. It's relatively easy for a hacker to craft phishing pages because the barriers to entry, the hurdles to overcome are pretty low, right? Say, for example, this Facebook page. If you are familiar with your web application concepts, it's effectively just HTML, JavaScript, right? They're all accessible through the browser console. You can F12, open DevTools, copy paste, host it on your own, right? Even the JavaScript, if let's say there are like course restrictions, you can strip out the code on your own, host it locally, then no more course restrictions. So you can serve this page within a matter of like 1-2 hours, right? So easy. All you have to do is just send the person the malicious link, he types it in, redirect it somewhere, you capture it, you can use it on your own. Done. Now, post-MFA days, things start to get a bit more complicated, right? Credentials alone become insufficient. Some MFA prompts examples are your push notifications, like the one shown in the picture over here. You just have a pop-up saying that, like, do you approve this login? Do you deny it, right? Other than that, you have OTPs, one-time passwords. They can be sent to you via your SMS or emails. You get it, you type it in, right? And it's supposedly phishing resistant. Is it really phishing resistant? Here's what we're going to try to explore. So back in 2022, anyone familiar with the Uber hack? Heard of it before? What happened? So Uber's employee SSO account actually got compromised, and Uber actually had MFA enforced on their SSO service, right? What actually happened here was something called MFA fatigue attacks, where employee had his credentials compromised, and the attacker used this to continuously trigger login attempts to bombard the guy's phone with MFA attempts. So his phone kept popping up with notifications saying, like, do you approve this login? Do you approve this login? Do you approve this login? Right? And the aim here, what the attackers were trying to get, is to try and like just annoy him, to piss him off until he just press approve once, and then they're in, which is exactly what happened here. I encourage you all to go look up this attack. I have a link over here, but you can just Google like Uber 2022 hack. You'll find some very interesting things on what happened. The attacker actually accessed their internal messaging applications, Slack, and he started posting like not safe for work links, started scolding employees, started posting threats. So yeah, it's kind of like mischievous, and he actually took out quite a bit of data as well and like threatened to post it online. So if we assess this hack, right, we look at the variables that are involved here. Capturing the credentials through replicating login pages, it's feasible, right? That's not too tough. But the thing here that we want to look at is the MFA bombing portion. It's super noisy if you think about it. An attacker is going to trigger probably like 50 to 100 login attempts within 5 minutes. And this is not considered natural behavior, right? Like, why would an employee try to have so many login attempts within a short span of time? A good company with strong detection capabilities definitely would have some triggers set up such that if an account has triggered that many authentication attempts within a short span of time, it's going to alert them and they're going to lock out the account straight away, right? So it doesn't seem like it has some brute force element to it, which makes this attack not very elegant in a way, right? And in constructing attacks, stealth is a major part of it. And you want the attack to be successful, and at the same time, you want to go undetected. So in a way, this attack path, while has proven successful once, long-term wise, like, is this like a viable option? Not so much. So here comes the newer way, the more cool, elegant way of doing things. Man-in-the-middle phishing frameworks. There are a few out there, the most popular one being Evilginx. Sounds complicated. I'll try to water this down to help you guys understand. This part is going to get slightly technical, but I tried to constrain this to more familiar concepts for university level, which is basically your client-server model for web applications. So if you guys understand the client-server model for web applications, you should be able to follow along pretty well. Some origins. This is open source GitHub project and is created by a Polish security researcher called Kuba Gretzky back in 2017. So it's been around for close to 8 years. If my math might say 7 years, coming to 8 years, my math might be wrong there. High level, how it works. So you have the victim on the left and the real website on the right. Say Google login on the right. Evilginx serves to sit in the middle as a proxy, right? What it does here is that the request comes from, you know how in the original client-server model, the browser will make a request to the server gives the response back to the client. In this case, Evilginx sits in the middle. You send whatever request to Evilginx, it relays it over to the website. The response comes back from the website and you relays it back to the user. So the key part here is that whole communication channel, the proxy in the center can see everything, meaning your credentials, meaning the MFA that you key in. And the most important part of all is when you successfully authenticate, what happens? You get the session ID cookies, right? It comes in as set cookie headers. Everything is visible. So theoretically, are you following this part? Can high level understand what's going on? Nice, thank you. Just some illustration over here. I'm not too sure if you can, the photo is too small, but I'll try my best to explain. On the left, it's, what happens here is that like you buy a domain, a lookalike domain to Google's domain, and that's where you host your Evilginx proxy, right? So a victim is going to visit your fake domain. And you can see on the left, the headers, the host header, the referrer header, the origin header, is all accounts.not-google.com. That's my fake domain over there, right? It hits the Evilginx proxy. The code rewrites all these things to the original domain, so it goes off to the right place, right? So now everything is rewritten to accounts.google.com, and it'll go to the right web server. On the response side, once Google receives the request, it gives you back the original response, and it comes back through the proxy, right? And this time, what happens on the proxy is that it reverses the whole process, right? Your headers, instead of google.com, is rewritten to not-google.com. On the HTML JavaScript side, this one is a bit important, right? Because most web applications today, they heavily utilize JavaScript via script tags to include scripts, right? And without these JavaScript scripts, you're going to have messed up UI on your web applications, right? So the important part here is that at all times, when you're phishing people using the man-in-the-middle framework, you want the victim to stay on your site. You don't want the victim to be redirected to a different site. So meaning to say, all your JavaScript script source attributes, it has to be rewritten back to not-google.com as well, such that when the browser loads the scripts, it still goes through your proxy. And then the proxy retrieves the correct script for you accordingly, right? So this way, the user always stays on your phishing website. This is what the victim sees eventually, if you set everything up nicely. This is the Google login page. You can go to accounts.google.com, you see exactly the same thing. The only difference here is that the domain is not google.com, it's accounts.not-google.com, right? One thing to note is that there really isn't any cloning going on here. Compared to the pre-MFA days example where I showed you where you clone the HTML, you clone the JavaScript, this thing just acts as a proxy. It's taking the original response and returning it back to you with some slight modification. So as such, the website will work accordingly. If you type in your username, your password, it's going to go through. Visually, there really isn't any telltale signs other than the domain is not the right one. So how to configure? In the creator of Evilginx actually coined this term called fishlets. It's a YAML configuration file, right? It's quite a number of things to configure, but I'll just streamline and mention the key parts over here. There are 3 parts. 1, the domains to rewrite. As shown earlier, you have to route the traffic accordingly, and the authentication flow sometimes will include multiple calls to different domains, different URI endpoints, right? So some examples for like Google's authentication flow. Accounts.google.com is rewritten to accounts.notgoogle.com. You have api.google.com. You want to rewrite it to api-notgoogle.com, so on and so forth. And next thing, your HTTP post parameters. You have your username and password, which you want to capture. But if you think about it, in this case, it's not super important, right? Because you're not really interested in the credentials this time around. What you're interested in is the post-authenticated session cookies, which would grant you access to the user's account, right? But another thing to note here is that, like, nonetheless, username and passwords are always important, because in any attack that you go after, you start on a company, right? You can find different backend internal applications that require username and password, and they might not even have MFA enforced. So it's good information to have. Lastly, the one highlighted in red, your session cookies, the most important thing for this attack, right? Post authentication successful, set cookies header, you want it all. And then the way you're going to use the cookies is you have browser extensions which can change the cookies. You just paste everything in, reload the page. Ideally, you should land on the user's dashboard after that. Ingredients to make it work. You need a full understanding of the authentication flow. And how you grasp this is you use any application layer inspection tools. For anyone that's interested in like offensive security, you might have come across a tool called Burp Suite. Basically, it allows you to inspect network traffic, inspect all the post requests, get requests during authentication flow. And from there, that's how you figure out all the endpoints that are being called, what's the data you want to capture, what are the cookies you want to capture. You need a lookalike domain, right? Depending on like which domain you're trying to mimic, the price of a lookalike domain can range anywhere from like $10 a year to $1,000 a year. Google is a bit tough because the whole world is trying to hack Google, so it's going to be tough to find a lookalike Google domain for a cheap price. But you can think of other services that are not that popular, and you might find a cheaper lookalike domain for less than $10, right? Lastly, you need a cloud service to host your malicious website. You can use things like DigitalOcean, AWS, Microsoft Azure, whichever you're comfortable with, right? As long as you know how to set it up. Right? In total, you roughly need just a day's worth of setup time, which is actually quite straightforward. So, as mentioned earlier, this framework has been around for close to 7 to 8 years already. And it's obviously caught the eye of a lot of vendors, like Okta's, for example, Google, few other, if I'm not wrong, LinkedIn has also picked up on it. And what they've tried to do is they try to reverse engineer how this framework works and figure out how they can block people from using it. They can detect when someone is actually visiting a malicious page, and they're going to reject the authentication attempt and not issue the session tokens. We go back to this diagram that I showed earlier. Everything looks the same visually, but the one thing that's underpinning this whole attack is that it's hosted on a different domain, not the original domain, right? That's no way possible for you to grab hold of google.com and host your malicious site there, barring some major misconfiguration on Google's side. Like, say, for example, they forget to renew the license for the domain, which is pretty serious. It's not going to happen, right? You can bet your house on it, right? So this URL bar, that value there, you can actually retrieve it via a JavaScript attribute, which is your Windows location.href. Any website you visit, you open DevTools, you go in the console, you put this down there, you're going to see the same value you see in your URL bar. You can't change this. You can't fake this or mimic this, right? And these vendors are using this as like a reference point to validate, to make sure that you're on their correct domain. If not, they don't let the authentication through. So, before I go into the defense, I just want to note down here that like the defenses are generally highlighted, they're implemented in client-side JavaScript, right? And I'm not sure how many of you have worked with client-side JavaScript before, but it tends to be heavily obfuscated. They use this term called minified. It's not really compiling the code, but it just like streamlines everything, right? And all your variable names change from something tangible to A, B, C, and you can't really make out like what the code is anymore, right? On top of that, client-side JavaScript tend to link to more client-side JavaScripts, and they can span anywhere from like 1,000 to 2,000 lines of code to 50,000 lines of code. It's pretty infeasible to reverse engineer and trace like what the defense actually is, right? The better way to go about it is you have to develop some hypothesis of what's going on here based off your understanding of like web technology. And then you come up with test cases to go through process of elimination to figure out what's going on. It's a tedious process, but it gets fun after a while. So one major defense that popped up last year, right? And spoiler alert, it actually broke the way Evilginx worked. Like the existing open source Evilginx way of phishing is not going to work anymore with this defense, right? And this is what I'll explain over here. There are 3 stages. I'm going to go super slow here to make sure everyone understands. 1, there is JavaScript included on the page. And this JavaScript has code to gather browser telemetry. Some examples of browser telemetry are the Windows location href attribute, which is going to be used to be validated. Things like browser window sizing to make sure that you're not a bot, right? And so on and so forth. They're all hypotheses at the moment. Stage 2, the telemetry is gathered. Say, for example, it's formatted in JSON, right? And it's then encrypted and included as part of the post request parameter. Meaning now my authentication post request, aside from having a username and password parameter, there's this encrypted block there, which is basically the browser telemetry. The key part to note here is that it uses public key cryptography, right? Your private and public key to do this encryption. So it makes it almost impossible to reverse this encryption. I will explain this further in the next slide. Just follow along first. Stage 3. Post request parameters are set, it goes to the server, right? The server then validates the username, the password, and the encrypted block. It can decrypt it because it has the private key, right? It sees it, it checks whether the domain is the right domain. Is it google.com or is it some other not google.com domain? And if it's the right one, it allows it through. If it's not the right one, you're just going to get a generic error message saying that like you can't go through, right? So in that regard, like some key points to highlight here: the public key cryptography. You can crawl the JavaScript available and potentially find a public key, but it doesn't serve to be of much use to you, right? Because you can't decrypt it. That's not how public key cryptography works. You can't figure out what's the exact format the browser telemetry is generated, and you can't fake it and give it to the server, right? Other than that, the validation occurs on the server side, which means that you can't mess with it at all unless you have some way to hack Google server and like tweak the code there. It's just not possible as well, right? So some major vendors that have actually implemented this form of defense are Google and LinkedIn, right? At this point in time, I just want to ask, like, everybody kind of following what's going on here? Like, anybody wants a re-explanation or repeat of some of the parts? I'm happy to. Thank you. Okay, so to think of a way to bypass this defense now, right? I highlighted it in green over here, is that like we basically need that JavaScript responsible for generating the telemetry, the encrypted block, right, to execute on a browser tab that's visiting the Google domain, the right one, right? And it kind of is in direct conflict with how Evilginx works, because it's hosted on a non-Google domain. And you have a conflict here. How is it going to work there? So, how? I think the the name of the presentation already gives it away that there is a way around it. But before I go and explain, I just want to throw out a challenge. Does anyone have any potential ideas how they can get around this? Sure, go for it.
You if you run it on the actual website yourself, you copy the entry from that request and combine it with.
Yeah, you're onto something. That's actually pretty close. So how is there a way to automate it? Beautiful. He actually got it. Like wow, like that's actually super impressive. So yeah. The next slide here, I'll talk a bit about is like the concepts of what you just mentioned. So how many of you are sneakerheads or familiar with like the whole craze over like shoes and whatnot? I see your friends pointing people out already. Yeah. Right? Are you familiar with like people being so desperate to grab the shoes that they start reverting to like bots to cop the shoes and how the bots work? Which is, sorry, what's your name?
River.
Sorry? River. Am I saying it right? Yeah, so River basically called it out that you can use like libraries such as Selenium. Would you want to explain what Selenium is to everyone?
I haven't used it myself, but I believe it basically is like a stateless browser.
Yeah. And the key part here is that it allows you to automate browser actions, correct? So for sneaker bots, libraries like Selenium allows you to pretend you're using a browser in an automated fashion, execute your actions faster than other people can execute just so you can grab the shoes faster. We're going to use that concept to bypass the defenses over here. So, browser automation libraries, as River mentioned, use cases can stem from web scraping for data, personal automated tasking, clear your emails, collate daily news things. You can all do it from browser, right? And as mentioned, sneaker or ticket scalpings, like when Blackpink comes to Singapore on Ticketmaster, you join it and your queue number is 1 million plus, right? A bot might be able to help you with that, right? So how this can be used is that you spin up a browser in the background whenever a user keys in a username and password, right? On this background browser, you want to visit the original site, which is google.com, accounts.google.com, put in the username, put in the password, use the library interceptor features to extract out the rightfully encrypted block, generated encrypted block, pass it back into your existing phishing session, right? And that's the whole idea about it. Like, anybody lost so far? Like, is this clear? Nice. So, I need to disclaimer here that I wasn't the one that found this out. Like the writer, the author of Evilginx wrote an article last September in 2023, basically noting whatever we just mentioned, that you can use a background browser, put in the credentials, grab the special, he calls it a special token, I refer to it as an encrypted block, and then put it back into your original phishing session, right? The downside is that he realized that like this is actually a very groundbreaking feature in a way where it's dangerous. You can't just open source this thing because like then you start having people like hacking people's LinkedIn accounts, Google accounts, right? And his idea of this tool initially is meant for people in internal security teams to run hacking operations, to simulate adversary actions, and then to improve defenses, right? So he decided to release it as a pro version feature, and he wanted to charge somewhere between 1,002 to 1,004 euros, right? Which is pretty expensive. Probably only enterprise companies can afford this tool, right? Fun fact, he said he'll release it in Q4 2023 or Q1 2024. It's Q4 2024 and it's not released yet, right? So I somewhat needed this for work, and I was thinking like, what if I can build this on my own, right? And the resources available to me were that I have the open source version of Evilginx. There are plenty of browser automation libraries to choose from, right? River mentioned Selenium. There's another one called Puppeteer. And another fun fact is that Puppeteer was written by the Google Chrome dev themselves to handle browser automation. Right. On top of that, the author, Kuba Gretzky, he engaged in certain security podcasts that were recorded on YouTube, and he demonstrated the features, and he kind of gave away enough ideas on how to engineer this and how to build this. Right. So I took some time off to research. I dug through the Puppeteer APIs. I looked at his demos and I tried to figure out a way to build it. And I came up with a prototype, which is what I'm going to demo today. So effectively, I need to build a Puppet myself that spawns the browser. And I have built a testing application to send across messages to the Puppet. What these messages does is just to initiate the opening of the browser, keying in of the username, password, getting the key, the encrypted block back. Right? And this is what I'll demonstrate over here. Just a disclaimer over here that like I can't show the code here because I hard-coded my email, username, and password. I'll try to explain from here. So on the right is my client test application. On the left is my Puppet. As you can see, I have my name planted across there with the Puppet. So I'll press option 1 here. Option 1 just triggers it to start the browser. I'm gonna pull this to the side so you all can see exactly what's going on. Option 2 sends across the username and password. And you can see it typing in the username automatically. And then Casey gives me back the key, right? And then now it's the password. Option 3 sends the password over automatically. And then it closes straight away. So why it closes straight away is that I don't want the authentication from my Puppet to go through. I want the authentication from the phishing session to go through. You know what I mean? In case like some of the cookie values get burned earlier. So basically on completion of the authentication flow, I kill it straight away. I don't want it to go through. But as you can see, like it's returning me the encrypted block. And from here, I can use that block in my existing phishing session to continue along. Where is my browser? Yeah, okay. So the text here basically just highlights what was shown over there. If I were to put everything together, right, I just need to implement the test client functionality into Evilginx, right? The code base is written in Golang. Documentation is not readily available, but the code base is actually written and segmented really well. So if you take like a week to look through the Golang code to understand like the different files and how it's segregated, you should be able to figure out where are the additions you need to make, right? At a high level summary, all I'm doing here is that the only flow I'm changing is that when the login request hits, right, the Google login request hits, it triggers the execution flow for the Puppet, whereby I send a message over to the Puppet and say, hey, start the browser. Username and password comes in. Okay, hey, here's the username and password. Type it in, right? Give me back the encrypted block. When I put it back in to the original request, everything flows through nicely. The defense is bypassed. Some key considerations here is that like I wanted to write it in a way that it was adaptable to different scenarios, meaning to say, as far as possible, I don't want to hard code things specifically to work for Google only, right? If I were given a different scenario, say for example, like LinkedIn or a different vendor, I want to be able to make configurations to the fishlet YAML file and then control it from there. Right? So I want it to be extensible across different scenarios. I know I promised a live demo. Unfortunately, I have to renege on that promise because I've burned too many email accounts and IP addresses also, and it costs money. And it takes a lot of time to set up. But what I have prepared is actually a video of how Evilginx works with the Puppet. This video doesn't show the Puppet, but what I'll show you is that a full simulated login flow, a full capture of the tokens, and then using the tokens to access my own mailbox. So I'll pause the video along the way to explain. On the right here, this is the Evilginx framework. What I've done here is this, not sure you can see, but there's a link generator here. And this is the Evilginx proxy link. And it's hosted on accounts.google.com, like POOOGLE.com. That was the closest that I could find to Google. unfortunately, right? So on the left is the browser. I'm gonna clear the browser, what do you call it? The browser cache first to make this like a fair demo. So I'm copying the Evilginx domain and pasting it in the browser. So you can see here, it looks exactly the same as a Google login page. I know it's super hard to see here, but I promise you I'm not lying. It's not the original Google domain. It's the domain I own. So yeah. And I'll type in a username here. You can see it picks up the username has been entered over here. And basically what's happening and why it's taking longer than usual is because the background browser is spawning, is typing in the username. I can actually increase the speed of it, but like I didn't want to tinker with it. Once I got it working, I just left it as is. Yeah. So I have a message telling me that the token has been successfully replaced and it went through, right? And now for the password, I'm just typing a password in. It reaches the 2FA prompt, and this is where I receive the notification on my phone. I just press, I give it what it wants. I think Google's one is select the numbers that is shown on the phone. It went through. So it redirects to just a generic Google page, right? I did this intentionally, just for demonstration purposes, but the part I want you to pay attention to is this window now, the right side window, where I'm showing the sessions captured. I actually have a session capture now. And when I list the items in the session capture, it gives me the cookies that are captured from the successful post authentication, right? So I'm going to use these cookies in a web browser extension to force the cookies in, and I'll show you how it allows me access to the account. So I'm using a different browser now. I'm clearing the cache again. And if I go to mail.google.com, I should technically be asked to log in, right? Because there's no live session at the moment. So it rightfully sends me to a login page. But if I use a cookie extension editor, I clear all the cookies first. And then I paste my captured cookies. And just refresh and look at that. So yeah, this is actually how a full flow of Evilginx works. And Google is probably the toughest one to date. And just a fun fact, there's probably only like 3 to 5 people in the world who can do this right now because the pro version is not released yet. And it feels nice to be one of the 3 to 5 people. Yeah. So back to the presentation, where the actual problem lies. As you see, over the years, like MFA first came up, and you have your OTPs through your SMS and emails, right? And this was pre-Evilginx, pre-man-in-the-middle phishing techniques, right? So nobody really understood like how to bypass these things. But as these type of frameworks started to emerge in the market, right? These type of new ways of compromising accounts through man-in-the-middle phishing emerged. There's obviously been advancements in different forms of MFAs. The ones that have come up recently are something termed hardware-based MFAs, and they come in the form of like an additional security key. How many of you have heard of things like YubiKeys before? It's basically like a small little like USB device you carry around with you, right? So the difference here with using hardware-based MFAs is that it addresses the shortcomings of previous MFA protocols, right? The key part here is that the private key on the YubiKey is actually bounded to the domain that it's tied to. So in this case, like if you're using a YubiKey as an MFA for your Google account, it only can trigger the successful use of the private key if the challenge is triggered by google.com. If the challenge is coming from not google.com or google.com, the YubiKey will not accept the challenge. It'll block it, right? So I think what you can see here is that the previous forms of MFAs, the protocols did not account for this vector, right? And as you can see from the defenses that are being implemented by the vendors, it's actually more of like knee-jerk reaction kind of fixes. They're trying to like find novel ways to put plaster over a gaping hole, which works in some cases, but sooner or later someone is going to say challenge accepted, I'm going to find a way around it, right? So in a way, the old protocol is weak, there's a gap, and newer protocols of MFA serve to solve this problem. Although ideally it would be nice for people to all have hardware-based 2FAs, there are some real-world challenges to this, right? You have things like organization budget. Putting aside money to buy additional security keys, it costs money. And if you're a startup with not much funding, still in the early phase of the life cycle, right, it's going to be tough to convince your CEO or CFO to say, okay, I'm going to spend X amount of money on hardware keys, correct? The security value it adds can be immense, but not all executive decision makers will see it that way. We also have like adoption challenges, right? You have people who are so comfortable with just using their phone and pressing a button to do the MFA. And then you tell like 1,000 employees that like, hey, like now you all have to use this thing. You have to carry it, right? If you leave this at home and you come to work with your laptop, you need to go back home and bring your key again. So you're going to face challenges, right? And in some cases, you also have like big senior executives saying that like, no, I don't want to do it. It's too much friction. It's too much trouble. It's too troublesome, right? I hold this rank in the company. You must listen to me, right? It happens. These are challenges that you face in the real world, right? And this is actually where people like myself, people who do red team and hacking, we enjoy these things because that's what we exploit. So yeah, learning lessons. You're only as strong as your weakest link. Organizations can have huge cybersecurity budgets. They have the latest, coolest detection and prevention tools, right? But all it takes is the right employee to be compromised and everything falls apart, right? Generally speaking, the number of right employees are actually quite a lot, right? You have people ranging from HR managers, finance managers, IT sysadmins, right? And each of them would grant you access to a host of different things, right? You can go on LinkedIn today, search for a company, and within an hour, you'll find 20 prime candidates to go after because of the amount of information they put on LinkedIn, correct? So yeah, phishing is still a very potent risk in today's landscape. Something that was not really covered that I want to make a highlight of is also the role of strong IT policies within our organization. So with the emergence of like SSO solutions to provide ease of access to internal applications, IT departments also have to understand like when the wheel is being reinvented, you put new things into play. What are some of the security risks that it introduces and how it can mitigate them, right? Some simple low-hanging fruit policies such as enforcing MFA, hardware-based MFA options, at the same time IP address whitelisting, can go a long way in like trying to put a spanner in the works of hackers trying to use the MiTM framework, right? What I mean by that is like, say for example, if I compromise someone's Okta account, I have his cookies, correct? But the individual access to the backend applications, they're all IP address restricted to only the office IP address. I can use the cookies, I can put it in a browser, I'm still going to get hit by a HTTP 403 or 500 saying that like, no, you can't access because why? You only can access from office IP address. So these things might seem trivial, but they go a long way in actually making life extremely hard for hackers. Lastly, this is just more from any of you who are aspiring security professionals or want to consider a career in security, right? Understanding how tools work under the hood is really, really important. You come across free tools, open source tools over the internet that are super useful and helps you in your day-to-day tasks, right? But sometimes if you spend the time to look through the code, figure out how it's built, understanding the concepts better, it can actually serve to be super beneficial, right? Because at the end of the day, these open source developers, they do the work for free. They use their own free time to build these things, but they're humans as well. They make mistakes. Sometimes they don't have time to tend to all the bug fixes, right? and certain key quality of life implementations might not be done because they just don't have the time to do so, right? So use this as an opportunity to take on things like trying to implement your own bug fixes, implement new features, or even modify existing features to work it the way you want to, right? You help yourself to learn about an area that you're not so familiar with. At the same time, it helps to improve your engineering skills, right? One key mention I'd like to add here is that, like, with the emergence of ChatGPT, it's really quite impressive how it can help you to complete certain engineering tasks as well. I am not by any means a great code writer, but ChatGPT made me look like a spectacular engineer as well. So you can do a lot of things other than just roasting your Instagram account, right? And it's something that you can leverage for your own career as well. One last disclaimer before I move to the Q&A. There are some key topics that I intentionally left out, right? Things like delivering phishing emails into a victim's inbox, right? How to guarantee that it lands in the inbox instead of the spam box. Things like securing your phishing infrastructure such that it doesn't get picked up by automated scanners. Things like detection engineering for phishing links and ongoing attacks, right? All these things are super important to understand to craft a successful phishing attack. They can actually span their own individual talks on their own, and I've left them out. And if you are interested, I strongly encourage you all to research on it, read up on it, because you might find something that you like and you want to explore further. I hope this talk has encouraged you guys to, or at least spark your interest in security itself and to want to further your learning and understanding in this domain. And one thing I just want to call out here is that, like, this talk is definitely not intended to teach you how to hack your friend's account, right? So yeah, aside from that, thank you very much. I leave you guys with my contact details here. If you want to reach out to me to talk about any security related topic, ask about my experience, hack it, even ask me about how it feels like to jump out of a plane, shoot me an email, message me on LinkedIn. Other than that, I'm happy to take some questions for time being. Yeah.
So as far as I can understand, there's no SSL certificate for you. So there's no SSL certificate for you. So the SSL cert of the authentic Google and the phishing link is different. So wouldn't it be easier to just check the SSL cert? Because that's the whole point.
There is an SSL certificate. So I left this out. I apologize because I didn't want to overload it with too much information. So, are you familiar with certbot? Like it uses Let's Encrypt, if I remember correctly. Yeah. So Evilginx is actually built in with a certbot library, such that for whatever domains that you create, it automatically creates the SSL certificate for you. So as a proxy, when the client talks to the proxy, right, that's your first SSL termination. And then the proxy negotiates a new SSL communication with Google itself. So there is SSL, it's just it terminates here and then there's a new one. Now, to your point on inspecting the SSL certificate, that's a very nice point. I'll send you some links later, right? This has actually been researched by the creator of the project, right? And he noted that there is a way to see, to signature certain things about the certbot SSL certificate to identify that it's a man-in-the-middle proxy instead of an original website. And this is actually one of the detection, the way to detect that MiTM phishing is in use. Yeah. It's a bit more advanced, so that one I left it out for this talk. But yeah, great question. Yeah. Yeah, go ahead.
Wondering, like, you use Selenium in the middle to go and paste the username and password inside and get the encrypted block, right? But then how come the reCAPTCHA never block your Selenium?
Great question.
And don't you have silent reCAPTCHA or something inside?
So this one goes into a bit more of trial and error because if you notice, not every time the capture triggers, correct? And why then you only can hypothesize because you don't know the actual algorithm behind it, right? But what other researchers have found out and what my own testing have identified is that, like, the main thing here is that if the servers believe you're a bot, you're going to get a reCAPTCHA. If it doesn't believe you're a bot, you're not going to get a reCAPTCHA. So how you tweak your usage of things like Selenium and Puppeteer would determine whether it thinks you're a bot or not. Yeah. Does that help to understand?
Yeah. Maybe because you do on a real computer, so the server already knows that your computer is real.
Yeah, it could be.
So maybe you could
Some things, I can give you an example, like the speed that you type in the username and password.
yeah,
Right?
or
I
like more
intentionally
systems.
slowed it down. It's like, so when I got it to work, it was super slow. You saw how the thing was like that, right? Like in actuality, if you want to use it for your own personal task, you can just like pump the whole thing is pasted there within like half a second is that.
Yeah.
Right. So yeah. Yeah, go for it.
You mentioned that it's not possible to spoof the URL on the client side. So have companies tried to implement JavaScript that basically disables the entire login, the URL dependence not correct on the client side?
Disable the entire login, meaning to say?
So like they write JavaScript code that disables the entire page on the client side. So if the client is trying to access the page, but the page detects the wrong URL, then the client essentially.
I have not come across that. Yeah. That's something I might go take a look into. Yeah, but yeah. I mean, I believe there might be a reason why they haven't done it, but I'll take a look. That's a good question. Thank you. Anything else? Yeah.
Any chance you might release Team Puppet?
That's a good question. So I posted this on LinkedIn actually, and it caught the attention of the creator of the tool, right? And I've been in contact with him talking about, we're just exchanging like engineering ideas, right? But the one thing that I don't want to do is that like, this is not my work technically. I mean, I built it, yes, but the research work and the credit goes to the creator because he came up with the way to go around it. I just built it, right? And he's releasing it as a paid version, and this is not something I want to undercut as well. Right? It's a kind of like a honor and respecting that like you don't go and like eat people's rice bowl. Right. Yeah. I mean, to me, I did it more for learning and improving my engineering skills. And at the same time, right, like getting involved in the community and like just helping people out. So yeah. But what I would say is that like if you go look at open source code and you have some ideas and you want to discuss, I'm happy to discuss it. Yeah. Yeah. Anyone else?
I guess another question. So, thank you again.
No, my pleasure. Thank you.
Yeah, now you get to come down and grab your session. And I.
You're gonna make me
Let's say I don't have something. Like using the board, I send like the whole idea is to use the it's like reading that because I feel like just trying
No, you're right.
Well, I mean, use the whole thing, I think, as well. Yeah, no,
Hey, no way, bro.
use it fucking as a train, bro.
I don't know. I don't get
That's true. I'm really smart to finish. It's not said the question to be clear or I maybe the
I'm not getting safe. No, one century of ideas about you.